All right, welcome to our first lesson on vector addition and subtraction. And we're going to go ahead and just look at an example to see how we can actually carry out these two operations. So our goal is to look at these two vectors, A and B, and we're going to first go ahead over here and find their sum. Okay. Now, the sum of two vectors, a plus b in this case, has a specific name called the resultant vector. So when we add a and b together, the result is the sum, the resultant vector. Okay? So we can look at this in two different ways. We're going to start off with a geometric approach to this problem. So you guys saw the other day how you can draw vectors in on the coordinate plane. So we're just going to draw each of the vectors A and B in. So starting from the origin, I'm going to draw vector A, which is 2, 4. Then I'm going to draw vector B in blue, which is -3, 1. So here is my vector B, and here is my vector A. Now, what will the sum of these two vectors be? There's a way we can approach this, okay, a nice term that mathematicians like to use for adding two vectors together called head to tail. Basically, what that's telling me to do is attach the head of vector A to the tail of vector B. So all that means I'm going to do is grab onto vector B here and slide it. Oh, no, I don't want to move the whole graph. Grab the vector B and slide it to the head of vector A. So B has now moved to the head of vector A. And that gives us our resultant vector. So we can draw that in green here. Starting from the origin, our resultant vector is as follows. So this is the vector A plus B in green. So what are the components of that vector? Well, that's pretty easy to see. A plus B is going to have an x component of -1 and a y component of 5. So that's how we can approach this problem geometrically. Can we do it with a more algebraic approach? Well, some of you may have noticed something already. I'm going to write the two vectors out in component form. A is 2, 4, and I'm going to look at adding that to the vector B, -3, 1. Okay? I'm sure many of you young mathematicians have noticed that the resultant vector, -1, 5, can be achieved simply by adding together the x components of the two vectors and separately adding the y components of the two vectors, giving us the sum, or the resultant vector, of 2 plus -3, 4 plus 1, which gives us the vector -1, 5. So if we did not want to take this whole geometric approach, we can just directly add the x components and the y components of the two vectors together to obtain the resultant vector. So that probably gets you looking ahead to this problem. What is the resultant vector of A minus B? Well, since we know we can just add the components directly, why not for subtraction, can we just subtract the components directly? And that's exactly what we're going to do. So we're looking at here, the vector 2, 4, minus the vector negative 3, 1. So to get the resultant vector, a minus b, we will take the x components and subtract them, so 2 minus negative 3, and the y components, 4 minus 1. Again, 2 minus negative 3 because we're subtracting the vectors, 4 minus 1. Okay, so here we have a resultant vector of 2 minus negative 3, that's 5, and the y component is 4 minus 1, giving us 3. So the vector a minus b is equal to 5, negative 3. Now, many of you may be wondering, well, how can we look at this problem geometrically? Okay, well, that's an excellent question. So I'm going to go ahead and delete the resultant vector from adding the two vectors together, and then I'm going to draw in the resultant vector from our subtraction. So I'm going to draw in the vector 5, 3. So there it is right there. Okay. Now, I have my vector A here. In blue, we have our vector B. How can we get to the vector A minus B? Well, many of you have probably noticed that it looks like if I just flip around the vector B and have it go the opposite direction from the head of A, I get the resultant vector A minus B. So what does the problem of A minus B really come down to? Well, we could view this as the vector A plus the negative of vector B. Because when I take vector B and move it back to the origin to see what the components of this vector actually are, I see that the components of this vector, components of this vector are now 3, comma, negative 1, which is precisely the vector negative b, because if I negate the x component and then negate the y component of b, I will obtain exactly 3, comma, negative 1. So that is how we add and subtract vectors. Let's look at another example that builds off of stuff that you guys learned in the last lesson, meaning we're going to have to find the magnitude and direction of a resultant vector. So we're applying what we just learned from adding vectors together, and then we're going to build off of what you guys learned last time. So our goal here is to find the sum of the vectors and then find their magnitude and direction. Okay. So first, let's just go through this algebraically. I have the vector u plus the vector v. The resultant vector is going to be 1 plus 2.5, adding the x components together, and then I'll add the corresponding y components, so 2 plus negative 1, and my resultant vector is therefore 3.5 and 1. Okay, so magnitude and direction of the resultant vector. You guys saw that this just boils down to Pythagorean theorem and right classical trigonometry the other day. So the magnitude of the resultant vector plus v is going to be 3.5 squared plus 1 squared, square root of that quantity, which will give us the square root of 13.25, which is equal to 3.6, rounding to the nearest tenth here. Okay. Now, in order to find the direction of the vector, we're looking for the angle it makes with the positive part of the x-axis. So remember, we're going to look at tangent of the angle that represents the direction equaling the y component of the vector divided by the x component of the vector. So therefore, theta will equal the inverse tangent of 1 over 3.5, which inverse tangent, which will give us the direction of the vector is 15.9 degrees. So there we have magnitude and direction of the resultant vector. Okay. Now, just for fun, let's look at this geometrically. So I will draw in the vector u, which is 1, 2. So there we have it. There is vector u. And then in blue, I will draw vector v, which is 2.5, comma, negative 1. Ooh, need an arrow tool here. 2.5, comma, negative 1. Kind of tricky. And then I'm going to attach it to the end of vector u to get the sum of those two vectors. So I'm just going to slide this one over here. And you can see a little approximating is necessary here, but the resultant vector we expect should be 3.51, which is exactly what it looks like to be. 3.5 and 1 are the components of the resultant vector, which is exactly what we expected from our algebra.
Barefoot Mitchell.
Oh, it's still recording.